Hi guys and welcome to this video. Karina here, and today I'm going to be taking you through question 8 from this Leaving Cert higher level paper. This is a long question worth 50 marks and it is based on statistics and data. So let's get started. So in this question we're basically told about an online word game. So you're trying to guess a 5-letter word in as few attempts as possible, and you're given a score of S, where S is the number of attempts it takes to guess the word. In question A, we're told that in Ireland, players' scores are approximately normally distributed with a mean of 3.78 and a standard deviation of 0.36. A player is selected at random from the players in Ireland, and we're asked to find the probability that this player has a score of less than 3.5. So to do this, what we need to do is find a z-score for 3.5, okay? And then find the probability using this z-score that a randomly selected player has a score of less than 3.5. So first of all, let's write down what we know. We know that the mean is 3.87. We know that the standard deviation is 0.36. So to find a z-score, we're going to use the following formula, and that is x minus the mean over the standard deviation. So let's fill this in. So x is our sample, which is 3.5. Take away the mean and put it over the standard deviation. So let's see what z-score this gives us. And that gives us a z-score of minus 1.03. So we're looking for the probability that x is less than 3.5. But because we've now found the z-score, we can rewrite this as the probability that z is less than minus 1.03. But we don't really like that there's a negative here for when we look at our table in a minute. So I'm going to change this. So the probability that z is less than minus 1.03, I'm going to change that to 1 minus the probability that z is less than positive 1.03. So now let's find the z-score of 1.03 in our log tables. So when we put in our z-score into this, you can see here in the z-score column, when we find our z-score, we then find the probability, okay, or the proportion that is below that score. So you can see here, if your z-score is here, maybe this looks like 1.4, say, okay? And then it gives you the proportion that is below it. What is the probability that z is less than 1.03? So we have 1.0 here, 1.03. So that is 0.8485. So it is 1 minus 0.8485. And let's see what this is. It's 0.1515. So the probability that a player selected at random has a score of less than 3.5 is 0.1515. This is our final answer, and for this answer, you're going to get a total of 10 marks. In question B, we're told that a random sample of 64 Galway players has a mean score of 3.74. Based on this, a local newspaper claims that Galway players have a different mean score to players in Ireland. Use this information to construct a 75% confidence interval for the mean score of all Galway players. Use the standard deviation of 0.36 in your calculations. So, to construct a confidence interval, we're going to use the following formula. And we're going to fill it in as follows. So this is going to be our sample mean, okay? So the mean scores of the sample, so that is 3.74 plus or minus 1.96 by the standard deviation, which we're told to use 0.36, all over the square root of the sample size. So the square root is 64. So let's put this into our calculator. First of all, we're going to put in 7.4 plus 1.96 multiplied by 0.36 all over the square root of 64. That gives us 3.8282. I'm going to write that down there. And now if we change the sign to a negative, I'm just going to back along here, change it to a negative, and we have 3.68 0.6518. So using these numbers, we can say that we can be 95% sure that the mean lies between the interval 3.6518 and 3.8282. So we can be 95% certain that the mean for these Galway players, for the players from Galway, lies between these two values. Okay, so this is our confidence interval. So that's the answer for this question. And for getting this confidence interval correct, you're going to get a total of 10 marks. In the next part of this question, we're dealing with hypothesis testing. It asks us to carry out a hypothesis test at the 5% level of significance to test the newspaper's claim that Galway players have a different mean score to players in Ireland. State your null hypothesis, your alternative hypothesis, your conclusion, and give a reason for your conclusion. So our null hypothesis here is that nothing has changed. So that is that the mean score for Galway players is the same as the mean score for all of Irish players, which was 3.87. Our alternative hypothesis is that it has changed. So that means that it is not equal to 3.87. We can conclude that from our 95% confidence interval, 3.87 is not actually within this confidence interval. So that means that the mean for Galway is different. So we reject the null hypothesis. We reject that it is 3.87. We accept HA, the alternative hypothesis. And the reason for your conclusion is that 3.87 does not lie within the confidence interval, and that interval was 3.6518 is less than or equal to the mean, is less than or equal to 3.8282. Okay, so we have now proved, using our hypothesis test, the 95% confidence interval, that the mean in Galway is actually different for the mean for the rest of Ireland. Okay, so for this question, you're going to get a total of 5 marks. In question C, we're told that a national newspaper conducts a survey on a random sample of N teenagers in Ireland. 35% of the sample say that they play the word game online every day. Based on this, a 95% confidence interval for the percentage P of all teenagers in Ireland who play the game every day was calculated as accurately as possible, and the interval was 26.5% is less than or equal to P is less than or equal to 43.5%. And we're asked to use this to work out the value of N, the number of teenagers surveyed. In this case, the way that they would have created this 95% confidence interval is as follows. So P hat plus or minus a P hat is the percentage, okay? Plus or minus 1.96 square root of P hat, again, the percentage, 1 minus P hat all over N. So this is how they would have solved for this confidence interval. So if you added it, that's going to give you that number. And when you use the subtraction button here, that's going to give you that number. So let's just use the positive number here. So we have P hat, which is the percentage, which we're told is 0.35, plus 1.96 square root 0.35, 1 minus 0.35 over N, we don't know what N is, and that is equal to 0.435, okay? So that's the proportion that's equal to 43.5%. So now let's use this to find out what N is. Now you could also do this using the negative sign here instead of the positive sign, but then you'd have to let it equal to the lower boundary, which would be 26.5. So that would be 0.265. So let's start working this out here. So I'm going to leave my 0.35 by 1 minus 0.35 over N on this side and let it equal to 0.435 minus 0.35. So I'm after bringing this over here and divide that by 1.96. So I'm after bringing this over to the other side as well. So now let's just work out what's on the right hand side. So I have 0.435 minus 0.35 over 1.96. And I'm going to leave that as 17 over 392 for a minute. And then that is equal to, I'm just going to work out what's on top of the bracket inside the square root. So I have 0.35 multiplied by 1 minus 0.35, and that is 91 over 400, or 0.2275 over n. So we want to get rid of the square root, so let's square both sides. So we're just going to be left with 0.2275 on this side over n, of course. And on this side, let's square 17 over 392, and we get 289 over 153664. So I want to find n on its own. So I'm going to swap this n here with this, okay? So I'm going to directly swap them. So I'm going to be left with n is equal to 0.2275 divided by 289 all over 153664. And see what we get there. And you see here that we get an answer of n is equal to 120.96. So then the value of n has to be a whole number, of course, because it is people. So n is equal to 121 people. That's our final answer. And for this answer, you're going to get a total of 10 marks. Now, in the final part of this question, we're dealing with a tree diagram. It tells us that a player wins the game if they guess the word with 6 guesses or less. The organisers of the game record the following statistics for players in Europe. So 80% of players win the game each day, 90% of players who win the game will play it the following day, and 25% of players who do not win the game will play it again the following day. Some of the information is shown on the tree diagram based on the 360,000 people who played on the 1st of June. The squares represent the proportions, the rectangles labelled play, win and lose represent the number of people who play, win and lose the game respectively. And then you're just given an example. We're also asked to assume that for the people who play the game on a number of days, winning the game on one day is independent of winning it on another day. So in question 1, we're asked to complete the tree diagram by writing the proportion of associated with each branch of the tree diagram into the appropriate square and writing the number of people who play, win and lose the game into the appropriate rectangle. So here on the 1st of June, 0.8 of 360,000 people win. So that means that 0.2 of 360,000 people lose. So let's work out 80% of 360,000 or 0.8, and that is 288,000. And then we're going to work out 0.2, which is 72,000. So then you remember that of the people who win one day, 90% of those will play the next day. So that's why we're multiplying it by 0.9 up here. So we have 288,000 multiplied by 0.9, which gives us 259,200. And then down here, 25% of those who lost will play the next day. So 72,000 multiplied by 0.25 will give us 18,000 playing the next day. Now again, when they play, 0.8 will win and 0.2 will lose. Again, 0.8 will win and 0.2 will lose. So let's work out 259,200 multiplied by 0.8, and that is 207,360. And down here we have 18,000 multiplied by 0.8, which is 14,400. 18,000 multiplied by 0.2, which is 3,600. So of those who win, 0.9 will play again tomorrow. Of those who lose, only 0.25 will play on the 3rd of June. Again, the winners, 90% will play, and the losers, 0.25. So let's work this out. So first of all, of 207,360, 0.9 will play. 207,360 multiplied by 0.9, that's 186,624. We have 51,840 multiplied by 0.25, that's 12,960. Of 14,400, 90% will play again, that's 12,960. 25% of 3,600 will play again, and that's 900 people. So there we have it. Our box is completely filled out. And for getting all the correct answers, you're going to get a total of 10 marks for filling out this tree diagram. The final question tells us that one person is picked at random from those who played the game on all 3 days. So from the 1st, 2nd and 3rd of June. Find the probability that this person lost on the 1st of June or the 2nd of June, or on both. All the people who played all 3 days are going to be this person and this person and this person and this person. So they're the total number of people. Now, who are the people that lost on the 1st or the 2nd or both of June? People who lost both days, they played here, they lost again, so here they are. People who lost and then they won, they're going to be here, lose, play again, win, so they're here. The people who lost on the 2nd day, they won, they played again, then they lost, so they're here. So they're going to be the bottom 3 boxes. To find the percentage or the proportion of people who lost on either the 1st of June of all the people who played the 3 days, we're going to add up these 3 boxes, okay, and then put it over the total number of people who played the 3 days. So first of all, let's add up the total number of people who played the 3 days. So that is 186,624, 12,960, 12,960, and 900. So we have 186,624, 12,960, and we have 12,960 again, and then we have plus 900. And let's add these up to see the total number of players for the 3 days. And that gives us 213,444. And now let's add up these 3, okay, to give the number of people who lost on either the 1st or the 2nd of June or both. So we have 12,960 plus 12,960 plus 900. And that's 26,820. So let's put 26,820 over 213,444. And let's see what we get. We get 745 over 5,929. So this is our final answer. That's the probability that of all the people who played in all 3 days, the person that was picked lost on the 1st or the 2nd of June or both. And for getting this answer correct, you're going to get a total of 5 marks. Alright everyone, that's all for this video. Thank you all very much for watching. I hope you found this helpful. I'll see you all in the next video.